Hi everyone, welcome back to Technical Mathematics. In lecture 5, we will be continuing with matrices and determinants. We will discuss about Cramer's rule in solving linear equations in three unknowns. So let's start with Cramer's rule. If we have three equations like this in terms of unknowns x, y and z, we may make use of Cramer's rule to find out the solution of these three equations. That is to find out value of x, y and z. Now as per Cramer's rule, the value of x will be equal to determinant of dx by determinant of d. Value of y will be equal to determinant of dy by determinant of d, and value of z will be equal to determinant of dz by determinant of d. Here d is a matrix of coefficients. Here you can see that we are having a1, b1, c1, a2, b2, c2 and a3, b3, c3 as coefficients of x, y and z. So D is nothing but coefficient matrix. Now dx is obtained by replacing column 1 with d1, d2 and d3. So here in matrix D, first column is having elements a1, a2 and a3. That is replaced with d1, d2 and d3 in dx. Now dy is obtained by replacing the second column with d1, d2 and d3, and dz is obtained by replacing third column with d1, d2 and d3. Now we may make use of Cramer's rule to solve three equations if and only if determinant of d is not equal to 0. If determinant of d is 0, then x will be undefined because determinant of d comes here in the denominator. So if this value is 0, then x will be undefined. Similar is the case with y and z. So Cramer's rule is applicable only if determinant of d is non-zero. Okay, now let's solve one problem based on Cramer's rule. So here is our question, solve using Cramer's rule. We have three equations here in unknowns x, y and z. The first equation says x plus 2y plus 3z equal to minus 5, 3x plus y minus 3z equal to 4, and third equation is minus 3x plus 4y plus 7z equal to minus 7. So let's see how to solve this using Cramer's rule. Now as per Cramer's rule, x can be calculated by knowing determinant of dx and determinant of d. Y is equal to determinant of dy by determinant of d, and z is equal to determinant of dz by determinant of d. Now as a first step, let's find out determinant of d. So determinant of d will be equal to determinant of the coefficients. So here in the first equation, coefficients are 1, 2 and 3. So that comes in first row 1, 2, 3. And in second equation, coefficients are 3, 1 and minus 3. So second row has elements 3, 1 and minus 3. And third equation has coefficients minus 3, 4 and 7. That comes as elements in row 3. Okay, now when we calculate determinant of this matrix, we will get it as 40. Okay, now the next step is to calculate determinant of dx. How to find out dx? Dx is obtained by replacing the first column of d with minus 5, 4 and minus 7. So here you may see matrix dx. Here the first column has elements minus 5, 4 and minus 7. The other two columns remains same as that of d. Now when you calculate determinant of dx, you will get it as minus 40. Okay, now the next step is to calculate determinant of dy. Dy is obtained by replacing the second column of d with minus 5, 4 and minus 7. So here you can see that second column has elements minus 5, 4 and minus 7. So that is how we get dy. Find out determinant of dy. You will get it as 40. Okay. Now let's move on to step number 4. Step number 4 is to calculate determinant of dz. dz is a matrix obtained by replacing the third column of D in terms of minus 5, 4 and minus 7. So here you can see that the third column of matrix DZ is having elements minus 5, 4 and minus 7. Other two columns remains same as that of matrix D. Now when we calculate determinant of DZ, we will get it as minus 80. Okay, now let's calculate value of X, Y and Z using these three equations. X is equal to determinant of dx by determinant of D. Determinant of D is calculated, it is 40. Determinant of dx is having a value minus 40. So X will be equal to determinant of dx by determinant of D, that is minus 40 divided by 40, that will be minus 1. So that is the value of X. Now Y will be equal to determinant of dy by determinant of D. Determinant of dy is 40. Determinant of D is 40. Therefore 40 by 40 we will get Y equal to 1. And Z value is equal to determinant of dz by determinant of D. Here we have determinant of dz as minus 80. Determinant of D as 40. So minus 80 by 40 we will get it as minus 2. So we will get values of unknowns X, Y and Z by using Cramer's rule. Okay, now let's see few questions related to Cramer's rule. Question number 1. Cramer's rule fails for dash. Option A says determinant greater than 0. Option B says determinant less than 0. Option C says determinant equal to 0. And option D says determinant equal to non-real. So you must be knowing the answer. Here the right answer is option C, determinant equal to 0. So we have seen that if determinant of D is equal to 0, then the value of X, Y and Z cannot be calculated because they are undefined. Determinant of D comes in the denominator. X is equal to determinant of dx by determinant of D. So if determinant of D is 0, then X will be an undefined quantity. So therefore Cramer's rule fails if determinant is equal to 0. Now let's see question number 2. Cramer's rule is not suitable for which type of problems? Cramer's rule is not suitable for which type of problems? Option A says small systems with 4 unknowns. Option B says systems with 2 unknowns. Option C, large systems. Option D says systems with 3 unknowns. So here the right answer is option C, large systems. Cramer's rule is not suitable for large systems because the calculations becomes very complex. Therefore Cramer's rule is not preferred in large systems. Okay, now let's move on to question number 3. Apply Cramer's rule to solve the following 3 equations. We have 3 equations here. You have to solve this using Cramer's rule and find out value of X, Y and Z. So please pause the video and try to solve this by yourself. Okay, now if you have the answer, here the right answer is option A, X equal to 1, Y equal to 2 and Z equal to minus 1. So you may check this by solving using Cramer's rule. Okay, so with this we are coming to end of lecture 5. In lecture 5 we studied how to apply Cramer's rule to solve linear equations in 3 unknowns. In lecture 6 we will have a review of matrices and determinants. We will solve few important questions from matrices and determinants, and with that we will wind up matrices and determinants, and from lecture 7 onwards we will start with the binomial theorem. Now for upcoming videos you may subscribe to Vadhyar Online Academy on YouTube, and to receive study materials you may subscribe to our Telegram channel using this link, and we have provided this link in the description of this video. So thank you. See you in lecture 6. Goodbye.